Okay guys, we're going to go ahead and do volumes of prisms and cylinders today. And there's really just one formula that you're going to need to know for this. Like I said before, we're not going to have any formulas for this, for our quiz, for any volume. Okay, but they're really pretty basic and extend on what we did. So a quick reminder, volume of a 3D figure is the number of non-overlapping unit cubes. You've heard this before. So area is going to be your unit squares that you can put down. Cubes is volume is how many cubes you can put into the interior of a solid. So Cavalieri's principle basically says that if you have two shapes, two 3D figures, whether it's straight up and down or slanted, if they have the same height and the cross section all the way up has the same area, then they're going to have the same volume. Okay, here's your volume of a prism. This is also going to be the same for your cylinder. Okay, so volume equals area of the base. So big B stands for area of the base times height. So here you can see your triangular prism. We would find the area of the triangle times the height. Same thing with this, even though it's slanted. Here, this is what you guys have seen in the past for sure. Length times width times height for your rectangular or square prism. Length times width times height for your cube. It's just going to be s cubed in this case because they're all congruent. So however you want to think about it. But this is your home base for all the formulas we're doing today, or all the shapes. I'm going to skip over this one and we'll go and get into something more interesting. So here you guys, we have a right rectangular pentagonal prism. Okay, so here's your base. Remember, your base is what's congruent and what's parallel. So we have a pentagon, so we're going to use 1/2 apothem times perimeter for this. Now I know that it's a pentagon, so I know that my central angle is 72, which means that this triangle here is going to be, or this angle here is going to be 36. So I'm going to break this guy up. So here's your 36 degrees. This is 5, so this is going to be 2.5 meters. We want to find our apothem. So I'm going to use tangent. Tangent of 36 degrees equals opposite over adjacent. And we solve that and we end up getting that our apothem is going to be 3.44. So my area of my base is going to be 1/2 3.44 times 25. My perimeter is 5 times 5, which is 25. Okay, crunch those numbers, guys, and you end up getting approximately 43 is what I got on my calculator. Your numbers might be a little bit different than mine depending on how you're rounding and where you're pushing enter along your calculations. So now I'm going to go ahead and put my area of my base times my height. So if I took this guy and put him on his base, then the height is going to be 7. Okay, I put him on that pentagon. And you're going to get approximately 301. That's what I got when I put this in. You guys may end up getting 0.1. You might be off just a tiny little bit, and I'll know that. Okay, guys, now we're going to get into something a little more interesting. We're going to do some conversions here. So it says the area at the right is a rectangular prism. Okay, so we have a prism we're dealing with, and we want to, first of all, estimate the volume of the water in the aquarium in gallons. Okay, so we're going to go ahead and take care of step 1, then we'll deal with step 2. So it gives us a hint down here. When I find my volume, it's going to be in cubic feet, and then I'm going to convert it to gallons using this conversion here. Okay, so step 1, let's go ahead and find our volume. So our volume equals our area of our base times our height. Okay, so length times width times height, and it really doesn't matter when you're dealing with your rectangular or square prisms. And you end up getting 57,600 feet cubed. Okay, so that's how many cubic feet I have. However, I want to convert it to gallons. Okay, so just a little conversion reminder. When you're converting, your units have to be the opposite on the top and the bottom so they can cancel. So I know that 1 gallon, by this information right here, is equal to 0.134 feet cubed, cubic feet. That's going to allow these to cancel and just multiply straight across and divide. And you're going to end up getting 429,851 gallons. Okay, so that is going to be the volume of the water in gallons. However, it wants me as my second piece to estimate the weight of the water in pounds. So I want to basically find out what is the weight, or how many pounds do these gallons of water weigh, okay? So it tells me right here the density of water is about 8.33 pounds per gallon. Okay, so I'm going to bring this over here, 429,851 gallons, and I want to convert that to pounds, okay? So again, I want gallons to cancel, so I have 1 gallon for 838.33 pounds. These guys cancel out, and your final answer is fairly large, 3,580,658 pounds. We'll go through this again tomorrow just to make sure we're clear. Okay guys, the next thing that we're going to do, and our last one today, is going to be your volume of a cylinder. Notice it's the same formula. Okay, so volume of cylinder area of the base times the height. In this case, your area of your base is pi r squared. So I'm just going to pop through this really quickly to make sure that we're all on the same page. Volume equals area of the base times height. So, and it wants me to say it in terms of pi and round to the nearest 10. So volume of base is going to be pi r squared. So pi times 8 squared times my height. And then that's just going to be 768 pi centimeters cubed. Okay, throw that in your calculator, and you should get 2,412.7 centimeters cubed approximately. Okay, so straightforward, nothing crazy about that. Now this one's going to be more interesting. A cylinder with a base area of 36 pi inches squared and a height equal to twice the radius, okay? And I still want to find the volume of it. Okay, so I know that volume equals area of base times height, and the area of the base is 36 pi. And then it tells me the height is equal to twice the radius. My question mark is my radius, but we can find that. So 36 pi is equal to pi r squared. That's my area formula. These guys cancel. Take the square root, and you get r equals plus or minus 6. In this case, we'll deal with the positive 6. So my radius is 6, and then my height is going to be twice that. Now I have all the information I need to find my volume. Okay, so volume equals pi r squared times my height. This turns out to be 432 pi inches squared, which is 1,357.2 inches cubed. Have to catch myself on that. All right, y'all, this is going to be the second to last concept we'll talk about. So we just want to see the effects of changing dimensions. So let's just go through a couple original. There we go. All right, let's go through a couple demonstrations to see what's happening with this. So I'm dealing with a cylinder. The radius and the height are multiplied by 1/2. Okay, so let's start with our original. So area of the base, pi r squared, times your height. Let's leave it in terms of pi so we can really see what's happening. You get 432 pi meters cubed. Okay, now this is going to be where we multiply it by 1/2. So if I multiply this by 1/2, I end up getting pi 3 squared times 6. And you get 54 pi meters cubed. This is dividing by 8, or multiplying by 1/8. Alright? Now you guys, what's the relationship between 1/2 and 1/8? Well, that's just going to be 1/2 cubed. And so that's basically what you have going on. Just like we had, if all the dimensions are changed, then and we dealt with the area, it was multiplied by that number squared. Now it's going to be multiplied by that number cubed. You do not need to go through this whole process if you notice that. So it's going to be the same thing cubed. You can say 1/8 or 1/2 cubed, whatever works for y'all. And then for these guys, I'm just going to explain this last example. Find the volume of the composite figure. So you guys, you're basically just going to find the volume of this guy here. You're going to find the volume of this guy here, and then you're going to add them together. Okay? So the volume of my prism, of course, is going to be the area of the base times the height. The base here, guys, is your triangle. Careful with that. So 1/2 base times height. I'm just zeroing in on this triangle right here. Okay, or you can think about it base times height, whatever you want to think about. All right, so 8 times 6 times the height, which is going to be 9. So slow down with that a little bit, and you end up getting 216 meters cubed. All right, my volume of my cylinder, of course, is going to be area of the base times height. So pi r squared. Oh, I hit a roadblock here. What's my radius going to be? Okay, well what I can do is I can use my Pythagorean theorem, and then I can just cut it in half. Okay, so that's what we're going to do. 6 squared plus 8 squared is going to be c squared. You end up getting c is 10, so that means this is 10. Or you can recognize your Pythagorean triple, making this 5. So pi r squared times your height, which is 5 as well. So then you end up having 125 pi here, guys. Add these guys together, and you're going to get 608.7 approximately, as asking me to round to the nearest tenth, meters cubed. So nothing crazy, just watch out for those little steps there, and the conversions can be a little funky. And this is what we'll work on in class tomorrow.